the alkenes. We're going to discuss why they are also called an unsaturated compound. We have to be comfortable with naming the first four and drawing the structures for the first four, discussing the general formulae and have a look at the different properties of our alkenes. So the alkenes are known to be unsaturated hydrocarbons. Unsaturated hydrocarbon means that they contain at least one double bond between two carbons. Okay? That is the most important thing that we need to know. The alkenes are unsaturated, meaning they've at least one double bond between two carbons. Now, as you can see here on the right hand side is our example of an alkene. I like to remember alkenes in the way that E following A is the second letter alphabetically. So that means two, where ane went with the one. The ene goes for the two. So it's just an easier way of remembering our order and our single bond followed by our double bond. So ethene, C2H4. Now you can have a look at the stereochemistry in that. We will talk about that a little bit later, but you'll notice that both hydrogens above and below are off to an angle. Now that's just a visual representation of how they would be arranged in space. Propane comes next, and as you can see here, there are three carbons in a row. The double bond is placed between carbon 1 and 2 on the left hand side. Now in this situation that actually does not matter if you have the double bond on carbon 1, 2 counting from the right, it's exactly the same. Prop meaning 3, ene meaning a double bond, and then you sub in your hydrogens around it. So the general formula for the alkenes is CnH2n. Now, meaning that N, again, as last time, is the number of carbons. So if you have 6 carbons, H2 times 6, you would have 12 hydrogens. It's very, very simple, the general formula for the alkenes. So we're going to look at drawing the structural isomers of C4H8. C4, bute, H8, giving you the impact that it's an ene, so it's butene. So the first thing that I would recommend you do is you would draw your 4 carbons in a straight line. You would then add in a double bond, and then you'd add in the remaining hydrogens around it. Remembering that the maximum number of bonds that carbon can have are 4. So the first one, as you can see here, is 4 carbons in a row, a double bond between carbon 1 and carbon 2. And as you can see, carbon 1 has 2 more hydrogens because it already had 2 bonds from the double bond. Carbon 2 has an additional 1 hydrogen there because if you look at the left hand side, it has 2 bonds from the double bond. The right hand side, it has a single bond going from carbon 2 to carbon 3, which means it needs 1 remaining hydrogen. Butene. Notice the reason that it's 2 is because the positioning of the double bond is between carbon 2 and carbon 3. That is it. You can read from right to left in this case, or left to right. It will make no difference. 2-methylpropene. Still C4H8, but notice the difference. Your longest carbon chain there is 3 carbons, and you've placed a methyl group, CH3, your substituent, on carbon 2. So that's the 2-methyl part. The longest carbon chain is 3, given a prop, and we have our double bond for our ene. Now, I'll give you a brief introduction to draw the structural isomers of C5H10, 5-pent. In this case, again, it's pentene. So, very simple. 5 carbons in a row, add in your double bond, add your hydrogens around it. You can move the double bond in this case. So as you can see here, it's 1 pentene. Why? Because the double bond is between carbon 1 and carbon 2. Pent2ene. You can see it here, also known as 2-pentene. The double bond is between carbon 2 and carbon 3. You could have pent3ene, and you'd have the double bond between carbon 3 and carbon 4. So just be aware of that, okay? I want you to try the next ones on your own. So penthrene, 2-methylbutene, and 2,2, remembering 2,2 in this case, meaning that the positioning of the methyl groups, dimethyl, di meaning 2, so 2 methyl groups on propene in the 2,2 position. Have a go at that, sketch it out. Beautiful thing about the alkenes, properties. First three are gases. If we compare that now to our alkanes, where the first four gases, there's very little in the difference, but the impact of that double bond will be seen. The next 11 are liquids, and again, just like the alkanes, boiling point increases with length of carbon chain. Why? You need a higher level of energy to overcome the van der Waals forces between the molecules. Again, it's exactly the same as the alkanes. They're not soluble in polar substances like water because obviously they're hydrocarbons. There is no polar end there. So they will be soluble in non-polar substances like hexene. So going through that again, we've been able to define our alkenes. We've talked about what an unsaturated compound is. We've named them. We've drawn the structures and the isomers.